Next chapter, ratios, rates, proportions, and percentages. Ratios. Now, from a dictionary, a ratio is defined as a comparison of two numbers by division. Well, that's true, but it is also confusing. It is confusing because we often think of comparing numbers as trying to decide which one is greater than, less than, or equal to another. But with ratios, we don't compare numbers like that. Instead, we try to see how two numbers relate to each other. And so in maths, we could drop the word comparison and put relationship. So how do you show a relationship by division? Let's look at an example of a ratio. 1/2. Isn't that a fraction? It is. Actually, in mathematics, a ratio and a fraction basically mean the same thing. It's just that when we use a fraction in a particular way, we call it a ratio. In other words, ratios are just like fractions. The difference is how we use them to describe things in the real world. To clear that up, let's see how we can use the fraction 1/2 and the ratio 1/2. Mathematically, they both mean the same thing, 1 divided by 2. But in fractions, we usually treat it as if it was one single number. For example, if you're hungry, you might eat 1 apple. If you're too hungry, you might eat 2 apples. But if you're not very hungry, you might eat half an apple. We can use the fraction 1/2 just like we use 1 or 2 to show how many apples you eat. It's only that with 1/2, we know that it's only a part of an apple, a fraction of an apple. How about ratios? With ratios, we don't treat it like a single number. Instead, we pay attention to the numerator and the denominator because we use them to refer to different things. For example, let's say we have apples to share, and for every 2 people, we have 1 apple. In that case, we say that the ratio of apples to people is 1:2, or 1 apple for 2 people. You see the difference now? The math part is still the same, but in the fraction, both the top and the bottom numbers refer to the same thing, the apple. However, with the ratio, the top and the bottom numbers refer to different things, apples and people. A fraction shows a part of something, but a ratio shows a relationship or a comparison between 2 things. And you can see that mathematically they mean the same thing, because if you have 1 apple for 2 people, each person will get a half of an apple. Okay, now we know that fractions and ratios are basically the same thing. But since they are used differently in maths, sometimes they are shown differently. Often instead of the division symbol, a ratio may be represented like this. This means 1:2 or 1/2. For example, in this picture, we can say that the ratio of dogs to cats is 3:2. 3 dogs to 2 cats. And you can also write it as 3 dogs over 2 cats. They're just different ways to write the same ratio. Ratios are used all the time in the real world to represent situations. Let's say a gift basket has apples and oranges, and that there are 3 apples for every 1 orange. That means the ratio of apples to oranges is 3:1. 2 ways in which ratios differ fundamentally from fractions. First, for ratios, we can actually reverse the order of numbers without changing the meaning, provided we also change the order of items. Let's see the apples again. 1 apple for 2 people. So the ratio of apple to people is equal to 1:2, or 1 apple over 2 people. Each person will get half an apple. We can also write the ratio as people to apple equal to 2 to 1, or 2 people over 1 apple, and still each person gets half an apple. But for fractions, we can't do that, and if we do it, the fraction changes in meaning. The fraction 1/2 is half an apple. If you write it as 2 over 1, then you have 2 apples. Secondly, in ratios, we can give the relationship between 2 or more items. For example, the ratio of sand to ballast to cement in construction. In this case, we cannot write it as a fraction. And just like fractions, we can simplify ratios. The same way that 2 over 4 is equal to 1 over 2, 2 to 4 is equal to 1 to 2. Now this is where it gets interesting. Given a ratio, we can express each item as a fraction of the total number of items. For example, in the fruit basket, the ratio of apples to oranges was 3 to 1. Suppose that the basket has 100 fruits. How would we know the number of apples and oranges? It's easy. From the ratio 3 to 1, we have 4 items. That is 3 plus 1. Out of the 4 items, 3 are apples and 1 is an orange. So the fraction of apples is 3 over 4, and that of the oranges is 1 over 4. And so if there are 100 fruits, then there will be 3 over 4 times 100, which is equal to 75 apples. And there will be 1 over 4 times 100, which is 25 oranges. Let's take an example. Jen, Ruben, and Alan want to raise $200,000 for a business. They agree to contribute in the ratio 2 to 3 to 5. Calculate how much each one of them contributed. And so the ratio of contribution, Jen to Ruben to Alan, is equal to 2 to 3 to 5. The total is 2 plus 3 plus 5, which gives us 10. The total amount to be contributed is $200,000. Jen's contribution will be 2 over 10 times 200,000. That will be equal to 40,000. Ruben will contribute 3 over 10 of 200,000, and that is equal to 60,000. Alan will contribute 5 over 10 of 200,000, and that is equal to 100,000. Changing quantities in ratio. Now, when the quantity of an item changes, we might want to express the new value in terms of the old value. For instance, if the price of a watch reduces from 500 to 300 shillings, the ratio of the new price to the old price is 300 to 500, and that simplifies to 3 to 5. Or in form of fraction, that will be 3 over 5. So the new price is 3 over 5 times the old price. Let's take an example. The price of a radio increases in the ratio 3 to 2. If the new price is 2,400, what was the old price? And so the ratio of increase is 3 to 2. In fraction form, that will be 3 over 2. If we multiply this ratio by the old price, then that should give us the new price. So 3 over 2 times the old price, which we don't know, should give us 2,400. To get the old price, we multiply each side of the equation by 2 over 3. And that should give us 1,600 shillings. Let's look at another ratio, 80 kilometers per hour. At first glance, this looks like a single item, and yet we said a ratio shows a relationship between two or more items. But actually, there are two items here. Remember, we said that any number can be written as a fraction by just writing 1 as the denominator. 80 kilometers per hour is the ratio 80 kilometers per 1 hour. 80 kilometers per 1 hour is a type of ratio that we call a rate. A rate is simply a ratio that involves a period of time. Here are other common examples of rates: 50 meters per second and 3 meals per day. When we write rates, the slash sign means per. It has the same meaning as the over sign. Notice that in these ratios that we are now calling rates, the denominator always relates to a period of time, like hours, seconds, months, days, and so on. And that is why we call them rates. Notice also that the denominators are always 1. Can't we have something like 160 kilometers per 2 hours or 100 meters per 2 seconds? Of course we can, but most of the time when we have this kind of rates, we convert them into equivalent rates that have 1 as the bottom number. And that is because whenever the bottom number represents 1 unit of time, it makes it easier to compare different rates. For example, imagine 2 cars moving at different rates. The first one is moving at 120 kilometers per 3 hours, and the second one is moving at 150 kilometers per 5 hours. Which car is faster? You see, it's hard to tell when the rates have different parts in the bottom number. But if we simplify the rates, you see now you can tell that the first car is actually faster. Next are proportions. Proportions are a lot easier, especially if you know about equivalent fractions. If you have the fraction 1 over 2, we can have a set of equivalent fractions, like 3 over 6. These fractions are equivalent because even though they have different sets of numbers, they have the same value. So they represent the same amount. To understand proportions, let's look at the ratios again. We said that if we had 1 apple for 2 people, then the ratio of apples to people is 1 to 2. That is 1 apple per 2 people. So what if we had 6 people? How many apples would we need? If 1 apple is shared amongst 2 people, then 6 people will need 3 apples. So that ratio will be 3 apples per 6 people. So what we have here are equivalent ratios. Just like the equivalent fractions, they represent the same amount. So we can put an equal sign between them. When we do that, we have a proportion. A proportion is simply 2 ratios that are equivalent. One thing to remember, in order for 2 ratios to be equivalent, they not only have to have the same value, they also have to have the same units. That is, they must represent the same thing on top and the same thing on the bottom. This is a proportion because the top numbers are both for apples and the bottom numbers are both for people. But what if we change the top number to be oranges instead of apples? 3 oranges for 6 people is not equivalent to 1 apple for 2 people. So even though the numbers are still the same, this is no longer a proportion. Or what if we keep the same units but switch them in the second ratio so that people are at the top and apples at the bottom? Are they still equivalent? No, this is not a proportion either. 6 people per 3 apples is not equivalent to 1 apple per 2 people. But if we switch both sides of the equal sign, this is still a proportion. And so the units must be the same for both ratios in order to form a proportion. Knowing that, The next question will be, what do we need proportions for? Proportions are used to find an unknown value from a set of known values. For example, let's suppose we have a big party and 40 people are invited and we want to know how many apples we need. We can calculate that. We know that one apple is shared by 2 people. Let's take that ratio and set up an equivalent ratio for 40 people. The key thing to set that equivalent ratio is to ensure that the units are corresponding, apples at the top and people at the bottom. We know the number of guests is 40, but the number of apples needed is unknown, so we put a letter N. This is how proportions work. We will have 3 knowns and 1 unknown. We can easily find the unknown number using a procedure called cross-multiplying. So we shall have 1 over 2 is equal to n over 40. If we cross-multiply, 2 times n is 2n. 1 times 40 is 40. So to find n, we divide either side of the equal sign by 2, and that gives us 20 apples. The items represented in a proportion are said to be proportional. So the number of people and the number of apples are proportional. There are 2 types of proportions, direct and inverse. 2 quantities are said to be directly proportional if they increase or decrease at the same rate. That is, if one increases, the other increases, and vice versa. In our example, the number of apples and the number of people are directly proportional. If one increases, the other increases. In inverse proportion, when one quantity increases, the other decreases, and vice versa. For example, 4 men can finish a job in 2 days. How long will it take 6 men to finish the same job? The 2 items here are number of men and the number of days taken. In this case, increasing the number of men will surely decrease the number of days, and so they are inversely proportional. In this case, we work differently. 4 men take 2 days, and so 1 man will take 4 times the amount of time. That is 4 times 2, and that is 8 days. If 1 man takes 8 days, then 6 men will take 8 over 6. That is 1 1/3 days. Another example, a military camp has enough food to last 30 soldiers for 20 days. If 10 soldiers left the camp, how many more days will the food last? The quantities here are the number of soldiers and the number of days. If the number of soldiers increase, the number of days reduce. So the number of soldiers reduces by 10, from 30 to 20, and so we expect the food to last longer. But how longer? 30 soldiers will feed for 20 days, and so 1 soldier will feed for 30 times 20, and that is 600 days. So if 1 soldier feeds for 600 days, then 20 soldiers will feed for 600 over 20, and that is 30 days. So the additional number of days is 30 minus 20, which is 10, and so the food will last for 10 more days. Lastly is percentage. Now, a percentage is actually a fraction. Again, seriously it is. And because you already know about fractions, learning percentages will be a lot easier. A percent is not just any fraction. It is a fraction that always has 100 as the denominator. If it's a percent, no matter what the numerator is, the denominator is always 100. In fact, because the denominator is always 100, we don't even write it. Instead, we use the percentage sign. Whenever you see this sign in front of a number, it means a percent, a fraction with 100 as the denominator. Like this, it's 25%, so it means 25 over 100. In fact, the word percent itself says all about it. The prefix per means for each or for every, and cent is Latin for 100. That's why there are 100 cents in 1 shilling. So percent means per 100. How about percentages larger than 100? Can that happen? Yes, and it works the same way. 116% is equal to 116 over 100. This is an improper fraction. The fraction value is greater than 1. We use percentages to express a given quantity as a fraction of another, with the denominator being 100. For example, if John and Ben contributed 1,000 and 1,500 shillings for a business, we can express each amount as a percentage of the total contribution. Total contribution is 1,000 plus 1,500, and that gives us 2,500. The fraction of John's contribution is 1,000 over 2,500. To express it as a percentage, we multiply it by 100, and if we do that, we get 40%. Ben's contribution fraction will be 1,500 over 2,500. To express it as a percentage, we multiply by 100, and it should give us 60%. We can also express a change in quantity as a percentage of the initial amount, and in such cases, the original amount is always equal to 100%. For example, the price of a shirt increased from 1,000 to 1,200. Find the percentage increase in value. So the original price is 1,000 shillings, and that is equivalent to 100%. The new price is 1,200, so the price increase is 1,200 minus 1,000. That gives us 200 shillings. So we express the increase in price as a fraction of the old price. That is 200 over 1,000. And to make it percentage, we multiply by 100. And that gives us 20%. So the price increase of 200 shillings is equivalent to 20% of the original price. Alternatively, we can express the new value as a percentage of the original value. In such case, we shall get a percentage larger than 100. So we subtract 100 from the new percentage. So the new price is 1,200. As a fraction of the old price, that will be 1,200 over 1,000. And to make it percentage, we multiply by 100. That gives us 120%. So the percentage increment is 120 minus 100 to give us the same 20%. It works even if the quantity reduces. For example, in a weight loss contest, Joanne's weight reduced from 160 kilograms to 120 kilograms. Calculate the percentage weight loss. In the first method, we can first get the weight difference and express it as a percentage of her original weight. The original weight is 160 kilograms, and the final weight is 120. The weight loss is 40 kilograms. So 40 over 160 times 100 gives us 25%. So 25% is the percentage weight loss. Alternatively, we can express the final weight as a percentage of the initial weight, and then we subtract it from 100. So 120 over 160 times 100 will give us 75%. So 100 minus 75 will give us 25%. Same answer. When given percentages, you express them as a fraction. For example, what is 16% of 54,000? So 16% means 16 over 100. So 16 over 100 of 54,000 is equal to 16 over 100 times 54,000. And that gives us 8,640. Another example. The marked price of a suit is 2,800. If a customer is given a discount of 5%, how much will he pay for the suit? Again, we have two ways of working this out. The first method, we find what is 5% of 2,800 and then subtract it from the marked price. So 5 over 100 of 2,800 is 140 shillings. That's the discount. To get the buying price, we subtract 2,800 minus 140, and that gives us 2,660. Alternatively, we can say that if the marked price is equal to 100% and a discount of 5% is allowed, the buying price will be equal to 100 minus 5, which is 95%. So now we work 95% of 2,880. 95 over 100 times 2,800 gives us 2,660, the same answer. What if the price increased by 5%? We could add 140 to 2,800 to get 2,940. Or we add 5% to 100% to get 105% and work what is 105% of 2,800. So 105 over 100 times 2,800 will give us 2,940, the same answer.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.